I definitely can't start over, but I will definitely be talking more about this information. I can sort of go over what I've drawn so far. So I apologize if the music was too loud. I've turned it down now. Essentially what I was saying was this. These are what the pole pieces look like in the 1C and 1D. If you want to simplify that, we could draw it as just a rectangle. And within that, this is the XY looking kind of straight down on it. If you have currents that are being induced inside of their eddy currents, they're going to create a magnetic field that's going to be moving in the Z plane. And then here I was saying, when you have current flowing through a wire, you can use your hand, your right hand, and your thumb is indicating the direction of the current. So your fingers are indicating the direction of the magnetic field that's being generated by that current. Over here, I was saying, inside of this simplified, this guy, let's just draw it as a rectangle. If that was a big solid piece of steel, and your eddy currents, if you have eddy currents that are being generated inside of that, which all it takes is for a varying field for this to be in a presence of a varying field or a moving magnet, then you will have eddy currents that will be induced. Those eddy currents will generate their own magnetic field that will be in opposition to the major field that induced the eddy. And that's the monkey wrench in the works. That's your gremlin. That's your inefficiency in a system. You want to minimize that. And so in order to minimize that, you simply slice this. And so that's why all the pole pieces in a cutter head are segmented. Right? It's a segmented piece of steel because that then, and not just segmented, but laminated, separated. There's no electrical contact. And so that minimizes each one of these eddy currents to being very small. And so each one of them has these very small fields that I drew around them. And if you can then picture in your mind, well, that's going to be way less of a problem, right, than this. So you've mitigated eddy currents by having this sort of sandwich steel arrangement to your pole pieces. And that's not just in cutter heads, in these mono heads, that's in motors as well. And anything really that has something that has either an altering magnetic field or a moving magnet that is either sort of a generator or a motor or kind of an arrangement, you typically want to mitigate eddy currents. Over here, I was saying, hey, well, what's the deal with a coil? Why would you have that particular shape? Because it seems to me like a piece of wire generates its own field. And again, I'm sorry if I'm reiterating information here, but somebody did in the chat say that my music was too loud. So I've lowered that significantly. And I'm now trying to go through this again really quickly. So, why wouldn't you just use a huge gauge wire, which is kind of what I tried to draw here, and just run current through that? Well, they do have things like that. You can buy something to start your charcoal grill with, which is a huge piece of steel that has current run through it, but it does not generate a large magnetic field. It's not like it's a big electromagnet. So what you want to do is take a piece of wire and run it over itself many times, because as the wire is thin, it will make these little fields, but then when it stacks on top of itself, it will have an additive effect, and it will start to make very, very big fields around itself when you have many turns to that coil. So the length of a coil will sort of, the length, and I mean length of wire that was used to make that coil, will determine the actual strength of it. So over here I started to say, oh, and by the way, also too, I was also saying forces. If you, eddy currents are sort of an example of Lenz's law. If you want to know more about Lenz's law and all of this check out Electro Boom, because he has a really funny, he's awesome, by the way, and I love his stuff. He's got a great sense of humor, and he seems like a really awesome guy. But check out his video about this, and you can see him drop a magnet through a copper pipe, because a magnet moving through something that is circular like that will have these currents being induced in it in exactly the right pattern to create fields that will be in exactly the right orientation to provide resistance to the force of gravity, and that magnet will drop more slowly than it would if you just dropped it. So you could drop a neodymium disc magnet through a piece of copper pipe that you can buy at the hardware store. You can buy both those items at your hardware store, and you can try this yourself if you don't believe me. And it's really fun. It's cool, actually. But he shows that. So what I was saying was gravity, just like magnetism, just like the weak and strong nuclear forces, they're all the fundamental forces of nature. So cutter heads are actually an example of one of the fundamental forces of nature, which is cool. Square doesn't really work as well. So if you had a coil, which was a bunch of turns in a square shape, that does not work really great. And the reason being that when the fields, oops, excuse me, I dropped my marker. It doesn't have the same additive effect as a circular pattern does. When you do it in a big square, you got this big open space. It doesn't work as well. At the beginning of the video, I had what's called an air coil in my hand, what I call that. And it's sort of a flattened donut. I also said sort of a calamari shape. That works fine because it's a really nicely concentrated field, sort of like a circle, but it's got some limitations as far as physically its dimensions. And also, it forces you to have a certain shape to the armature. So in the 1D and 1C, the arms are sort of, they're not circular, but they're a square, and it's a small square, and it fits really nicely inside of the hole of the middle of the coil. Whereas over here, in the calamari version, you have to have a fin. So it's funny, it's like the C theme. So in the air coils, you have to have a fin that goes in there that's on the armature, and that's what's getting moved around by the delta of the fields that are being generated by the coil inside the magnet, inside the pole block for the 5C. So that's the 5C, is that air coil. The round ones are the 1D, 1C. Here I was reminding people of the stuff from prior stream, which is, bar magnets, north-south. You've got, flux lines. Those flux lines have an orientation. If you take those poles and you bend them together, which is what a horseshoe magnet is, then you distort that field and you start to have lines. And I can sort of redraw that really quick because I drew over it, and so it's sort of hard to see what I'm saying. But yeah, so what ends up happening is you get these sort of arcs, and some of them almost become straight lines. And again, I apologize. I'm not an artist, so yeah. Straight out. And so one of these is going to be north, and one's going to be south. And so right in the middle, right here, right inside of here, that's why I was drawing over it before, is where you've got the juicy flux. And so the dimension, the shape of this field in combination with the shape of this field, right, in combination with the shape of the pole piece, in combination with the shape of the armature, is how every cutter head actually is functioning, and why each design is slightly different. They had to make designs a little bit different just so that companies wouldn't sue each other, but also because if you wanted to make them one way, then a certain decision would ultimately mean that you would have to make a certain bunch of other decisions about the shape of the things. And so in some ways, some decisions forced aspects of shapes of dimensionalities of other parts, right? When you make a decision about one part, it sort of has an impact on the other. And that's something I'm really going to go over when I put all this stuff back together. So when I take all these parts I've been working on and actually put them back together and make a real working cutter head, which you will actually see on screen on a live stream right here, I will be sort of closing the loop on all of this, and I will, be showing you guys how it all comes together. And also what I was mentioning is, it's very Gestalt sounding, right? And it really is. It's a bunch of parts put together, but when you put them all together into a system, it becomes more than the sum of its parts. And they really do. It's a beautiful thing. And it's really it's a matter of not just the physical engineering, but it's not just the dimensional engineering, it's also the electrical and the electromagnetic and all of that. Did I want to mention anything else? No. So basically what we're going to switch to right now is some pre-recorded video that I'm going to narrate. And yeah, the music you're hearing is Brian Gardner. These are all his tracks. Did not write or was not involved with any of them. So I also mentioned that in the beginning of the video I had a mess of coils, and I was saying, evolution, right? Everything starts from something. This is a trilobite purchased in Amsterdam, even though it came from the United States. I had a mess of coils, and I was saying I started, and they were. It's not like I was brilliant at it just right off the bat. It took a long time to get good at it and to refine the materials that I used and whatnot. My very first coils were 3D printed forms that I was rolling onto. And so what I'm going to show you really quickly here is the pre-recorded video to show you how to make these in AutoCAD. So we're going to actually make these forms on screen here, and I'm going to narrate that. I'll give you a couple of pointers about CAD if you want to use CAD. I know a lot of people don't like to use it and use SolidWorks or whatever. Blender. Doesn't matter. It's pretty much the same process in every software like this. And so what I've made is the ability to print this out without doing any sort of supports or anything. And my printer is really old, so you get bad lines for the starts of prints around circles. So we're going to use a file and stuff to clean that out. We're going to glue this together. We're going to make a coil. And then after we make a coil by hand here, we're going to make a really quick speaker, and we're going to drive that speaker from some audio, and it's going to actually work. And now it's not going to be a great speaker. It's not going to be anything you're going to actually use. And in fact, you are going to be forming part of the speaker, but it will work. And that's the most important thing. Oh, okay. I'm just going to slam into everything then. Awesome. Yep. Good deal. Okay. All right. So, let's jump right in. What I'm doing is just starting by drawing a circle, and I'm sort of mulling over in my head what size I want that circle to be. And now I'm going to draw another circle, and you can see that little green dot that formed in the middle of the first. So in CAD, you can have it show you certain visual cues. Now I'm grabbing the larger circle, and I'm looking at the radius or the diameter. You can see I just changed the diameter. Oh, and now I just changed it from 2D to 3D dimension. And I've also done something called press pull. And I have a lot of shortcuts for all these commands, so I've created keyboard shortcuts. What I did just right there was copy and paste. I just selected and copied and pasted. You can also select, and as you see, you get those arrows. Again, that's a setting, so you can turn those on and off. And now I've grabbed that other circle and I'm going to change the radius of it, make it wider. Okay. All right, now we've got another circle stacked on top of it, copied and pasted. Now I'm going to make that just slightly bigger. Pull that up. And we are forming what we're actually going to spool the wire onto. And I'm sort of thinking right now about what height I want this to be. So I pulled it out a certain height, but I can always go back and change it and add to it. So once you press pulled an object, and that would be changing lines into what's called a 3D solid. Once it's a 3D solid, you can then modify that 3D solid in various ways by extruding, or in that case, a simple press pull. We'll extrude later and I'll show you that. So you can see that I can move these objects, and there's a little green dot that, or circle I should say, that appears in the middle of certain things when you hover over them. So it allowed me to grab the center of the bottom of that. And now you can see, sometimes it's tough to get at, to see that other reciprocal green dot, or circle. And I'll show you later that changing your perspective with that will allow you sometimes to get handles, which are what those are called, that you can otherwise not get at certain other perspectives. So this is cool, that's fine. That looked like a coil bobbin, but if I wanted to 3D print that, at least on my printer, I would have to print it with supports, one way or another, either small supports and it's standing up, or laying down like this and you get a lot of supports. So to avoid that, I'm going to print this or create this in two parts. So this part is going to have a lip on it, and that lip is going to insert into that part. So we're going to have to modify both pieces. We're going to have to create a wider hole in the center of the top, and we're going to have to create a lip in the shaft that's coming up from the bottom part so that we can join the two easily and glue it, and it'll stay together. So right now I'm going to just take some measurements because I don't remember off the top of my head what I made certain sizes to be. So that's how you can do that, is by using the measure tool. If something is a primitive line like a circle or a line, you can either see the diameter or the length of those things over there. In this case, radius and diameter, but if it was like a line, you could see the length of it as well in certain dimensions. And so you can change the size of a circle easily by doing that sort of thing. So I'm grabbing that, I'm bringing it sort of somewhere. Right, so this is where I was saying sometimes it's hard to see where you want to place something. Those handles don't show up in certain perspectives, but they do in others. And so that's what I was demonstrating right here. And what I just did was put it on one of the cardinal axes and on the same Z level as the top of that top piece, which is what you saw. So getting it in line on one of the axes and then also parallel on Z, but not on top of what I was just doing there. So now I've got this what I'm doing right now is making a handle. So the piece that I just made is what's going to insert. And what I did was, when I first started, I changed the radius of that circle because I need to make it just slightly smaller than the size of the circle that is going to be the center of the bobbin. So we can insert this in We can also remove it later, but it will sort of stay in because it's a tight fit, but it's not an impossible fit because I made it slightly smaller. I made it maybe 0.35 or 0.4 millimeters smaller. Then I had another circle that I drew that I made sure it was larger than the diameter of the circle that's the center of the bobbin. And I extruded it on an angle. So in extrude, you can define a taper angle, and that's what created that small taper there. Once I tapered that small section, then I just press pulled to pull out the rest of that handle as a cylinder. So now I've got three parts essentially: at the bottom wall, the shaft, the top wall, and the handle part. So now we're going to do that little lip. So when you select an object, you can move them discrete amounts. So what I just did was moved the shaft up 10 and the top wall up 20 millimeters. That way I can move them back down. I know each one goes down in increments of 10. And I don't have to try to get the handles anymore. I can just click on it and I can move it straight down 10 millimeters. And it goes right back to where I want. So it's an easy way to separate parts and then work on them individually and then put them back together, and to not have to do that monkeying around with the handles. Now I'm changing the radius of that circle. I'm gonna make the shaft a little bit wider so that I can lift the top of it. Right now I'm just measuring, okay, it's 3.5 millimeters tall. I'm gonna make a 3.5 millimeter cylinder the size that I want. Okay. But I also want another circle which represents the center of the shaft. And so you can type commands like I just did, which is press pull, or for me, I have it shortcutted as Shift P. Now I'm going to bring that guy down. And also, too, I'm sure there are people that do this for a living that laugh at what I'm doing right now, probably, or something. I don't know. I'm not an don't think I'm trying to say I'm an expert at CAD. I can just use it. That's all. So I'm accounting for the fact that, again, I want one part to be a little bit different size diameter than the other, so that when I put the two together, account for nozzle width when I 3D print or inaccuracies of the printer or whatever. I then take the size of one object and I make it slightly larger, and then I cut the hole in the other, and that way when the two go together there will be a little bit of size in between, but that will account for what I was just talking about. So what you're seeing right now is sort of the wireframe versus the solid. There are different views in CAD. And what's funny, I didn't know that when I first started, so I was drawing everything in the wireframe, which was tough. And then I learned that you can change the way it skins stuff. Duh. That was a fun thing to discover. So when you draw individual shapes, you can put them together by selecting them both, and or excuse me, by typing union first and then selecting them both and then hitting enter. And I always make that mistake. Always try to select the stuff first. Some commands you have to select things first. Other commands you have to type the command first and then select the things and then hit enter. So it just depends in CAD what command you're talking about. There's a certain order of inputs. So right now I'm clicking on something that you can't see. In the bottom right hand corner there's sort of a settings icon, a geared wheel, a cog wheel that will bring up the settings window, and in there you can define your keyboard shortcuts. So I've got Shift P for press pull, Shift M for move. Just C by itself is a circle, or L by itself is a line. Those are predefined. And Shift S is solid edit, and Shift 1 is for measuring a straight line. Shift 2 is for measuring circles. I have a bunch of things shortcutted. And now you can see I've sort of put everything together. That's what we're going to create. And now you can see I'm changing the perspective. But then when I click on one of them, you can see it said that it was an unknown perspective. Now it says WCS, which is your world view. So sometimes when you do certain commands like press pull, your view will change to an unknown. If you want to get back to that, which means that when you press on like one of the sides of that cube, your drawing will look skewed. So to fix that, you just change your view to world. We'll resolve that problem. So basically, that's it. We're going to switch back now to this. We're going to clean up these parts. We're going to glue them together. We're going to wind a coil onto them, and we're going to run some audio through it, and that will be the end of the stream. Look out, puppy. Sorry, Bob. My dog got comfy. I feel bad. Okay. Sorry, dude. Sorry. What I typically use for this sort of stuff is an X-Acto, and to tape that right there really helps, because otherwise it keeps unscrewing on most X-Actos, which is a pain in the butt. Hi, Bobby. Hey, puppy. Hey. Whoops. There he is. There's a doggo. Okay. So a little file action usually helps. If you're good, just sort of circling around. Don't cut yourself. Please don't cut yourself. All right. So that's typically how I will clean up parts like this, is to do that sort of thing. That first one I printed without like a little slot for us to start the beginning of the coil. So I went ahead and added a little slot, which I'm not sure if you'll actually be able to see. There's a little, at the top part of it right now, there's a little tiny slot. Opa. Send of things doesn't really matter quite as much, but I just used the squared end actually because that fit in best, and just ran it through there. That works just fine. So I was saying before, we want a decent enough fit, but we don't want this to be over the top. I can tell that there was some distortion to the print at the bottom, so I'm going to take a little bit more of that out. On my printer, it will do that. Again, I have an old printer. I need to update it, but I've been more concerned with updating the tooling that I have than the 3D printer. Okay, cool. So we can put it on and we can take it off. We're not going to glue it. And that's what the handle is for. Once we put this guy on, we can actually hold this and wind it. So I'm going to be providing what we just drew on screen as downloadable STL files that you're going to be able to go ahead and print yourself, and you'll be able to do everything that you're seeing me doing right here tonight at home. You can do this experiment yourself, and you can drop all the parts on the floor too. Okay. So when we put this together with this, with the dog hair that's stuck to my finger. Looks like I need to clean that up a little bit more, make it fit, which is fine. Yeah, like I was saying, my first layer, which is essentially all this it really is 1 or 2 layers, always comes out with really bad lines around circles. It's not going to be like a hugely deep fit, but it will fit together, form a bobbin, and allow us to make a coil, wind a coil, I should say. Make sure that I clear the lip with that little slot, so it looks like I didn't quite make it big enough. That's okay. I will correct that before I post it the STL files. I'll make this better. I'll go a little deeper. Try not to ruin it on screen here, but just make that channel a bit taller. And just in case, I'm going to try actually put it together with some wire on it. So this is what I'm going to use. You can buy this all sorts of places. I'm not even going to go into how many places you can buy enameled wire from, but you can buy it from all sorts of places, and you can also pull it out of things like old transformers. So if you got something that's broken but it still has power, you can take the transformer out, you can take it apart, and you can pull this wire out, or an old motor. Either way works. And what we're going to do right now is just take this and put it through. Take a certain amount through and put it into that slot I'm doing. And maybe I'm going to take a little bit more because I want a nice long lead for this right now. So I've got quite a little bit of wire coming off. That's going to be the start of our coil. So now, take that, and we're going to take some super glue. So these are all things that everybody should have around for the most part. Maybe not the enameled wire, but you can, like I said, very easily get that. If you've got a 3D printer, you can print those parts. If you've got a friend that has a 3D printer, you can print those parts. You can go to your local library and print those parts, right? So there's tons of ways to get those printed. I'm going to use some, not only magnified, but just safety glasses in general. Whenever I work with epoxies or super glue, I always make sure to wear eye covering because you do not want to get super glue in your eye. That would be the worst thing I could possibly imagine. So don't ever do that. And I just had a little bit pool up on the tip, which I just kind of wiped on there, and now I'm going to spread it around. You don't need much. Like I said, I didn't try to even drip it onto the part. I just tilted this, and there was some that was on the end, and that's what I spread around on there. Now I'm going to take the other part and put it together. That shouldn't take too long to dry. But we do want to apply pressure. In the meantime, I'm going to reseal my super glue. We'll use that later again. And I'll show you a trick. So if you're curious, this is 32 gauge. You could use a variety of different gauges, but this one will be good enough for the experiment. Thicker the gauge, the hotter the coil is going to be. So if you're not wanting a lot of heat buildup, you would probably not want to use really thick wire. So you want to make sure that there's no residual. Right now, no residual super glue right there, because we're going to put this right here, and this will sort of help keep the thing together as well as give us something to hold on to, right? So it's keeping that on, but also giving us something to hold on to. And so let's just begin here. Let's start rolling this guy out. Really need to get better lighting, I think. I don't know what's best here. Anyway. Okay. Here we go. How many? Another thing that I should point out real quick. It's easy when you have these things like this to ruin it. So to avoid ruining it, simply, and not hard, very gently wind it around right now, temporarily around what you're going to be holding on to wind the coil. And this is your friend when winding coils, either on a machine or by hand like this, using some masking tape. And generally cutting nice pieces of masking tape, little strips, is really helpful to have little pieces. So we're going to make some little pieces, but in this case it's going to be a little bit of a longer piece. And yeah, I know the music stopped, but I'm just going to have it off because I don't want to have to repeat myself for this stuff here. So I'm sort of grouping that back together, and now I'm going to tape over it, and now it's out of the way and it's protected. Right? And so it's not flopping all over the place, which is important because now we're actually going to go ahead and roll this. And again, I'm not going to do anything fancy here. I've got other stuff which I'm going to show you guys in a later video, which is my actual coil winding machine. We're going to make some coils probably tomorrow. At least for the Presto 1D and 1C. If you're playing at home and you've got any, yeah, Distrovia. I have a little quick sip. Oh yeah. Oh, little chaser. Okay. So the point that I was trying to make right there was, on my actual coil winding machine, I have something for this to sit on, which will make it easier. But tonight, we're just going to do this by hand, straight off the spool. And we're going to go in all one direction, so we're not changing directions or anything. And it doesn't really matter, you know, count right now doesn't really matter because it's just a little example. You can go as many as you want that will fit. Being particularly neat about it, having each turn stacked really nicely ordered. Again, doesn't matter. This is just for demonstration purposes. So we're just going to start winding this here. And again, all in one direction. We're going to fill it out a bit. And it's going to be much easier to do that with that other lead out of the way by putting it on this end, winding it onto this end, and taping it, but in a way that is gentle and that we can remove the tape easily, and we're not going to sever the lead as we remove the tape, which is what I did there. Also, before I did that, I made sure to remove any excess glue from the bobbin, which is not something that I would normally do when I make these for real, because I don't glue them together, so that I don't have that sort of a concern. So here we go. 2, 3, 4, 5, 6. You get the idea. 7, 8, 9, 10. And so I'm just going to keep going. 12, 13, 15, 16, 17. Let's turn this way. What I'm going to do right now is just get a bunch off. And as you are winding, it's good to, you know, do sort of try to fill it out as evenly as you can. So move left to right as you're doing this. But if it's uneven, it's okay. It's your first coil. Don't sweat it. It's still going to work. Trust me. The fact that we've stacked this many turns already means that this thing's going to generate a field absolutely no problem. Oh, and by the way, I have made little notches, and so that's what you might keep seeing the wire get stuck on, and that's intentional. It's so that I can keep that from unraveling without using tape. But also kind of for the purpose that you're seeing right now too. So if it does kind of get haywire and get caught up on the side, it'll stop. But I can also stop it like I just did there. And that way I don't need a third hand. Third hands are really expensive. I don't know if you've kind of done the research on that, but geez, man. Is a mod that you don't want to pay for. Kidding. How's that cyberpunk going, by the way? Heard a lot of people say funny stuff. Okay, so this is getting to be pretty full. This is going to definitely create a field for us, no problem. It's actually going to be probably pretty nice. The bigger I make it, the more I can run current through it, and the more highs it's going to take without having as much heat and deforming. Another thing to take into consideration with heat is the smaller you try to make your shape to your coil, the more concentrated the heat is going to be, and it will get hot, hot, hot. So generally in heads that have a lot of drive to them, the coil is quite large for exactly that reason. So bear that in mind too. Not just shape in combination with the other parts, but the size will really determine the heat factor for your coil. And you want to minimize heat in a cutter head. Absolutely do. There's no reason why you want heat buildup at all. So what I'm doing is I'm done. We've put enough. We've filled this thing up already. I lost count of turns, but we're probably around 150 or so. At least 120. Again, I lost count. I know we made it past 100. I can see the beginning of the coil again, which is right there. So I'm sort of bringing this close to that, and I'm going to try to do a little trick where I'm pulling it into between the existing turns and the top wall of the coil, which is what I just did, which will sort of keep it there. Well, of course, on live stream, that doesn't work. That didn't work because it's 3D printed plastic and it's not as rigid as other types. So I'm not going to be able to do that little trick. That's okay. I'm going to show you what I am going to do. So I'm going to hold that wire back, and I'm going to get the top off the super glue. By the way, I am ambidextrous, which has really helped in doing this stuff over the years. So this is right where the coil started. That's right where I just ran that other piece over. I'm going to put a little tiny bit of super glue. Just a small amount. Doesn't take much to seal off a coil. You don't have to go all the way around. We don't want that because, and I just took a rip of paper and I'm going to sop some of that super glue up because I don't want a lot. If this coil does get hot and you heat up that super glue, that is toxic. Don't breathe it in. Do not do that. So again, safety first. Do not breathe in directly around this coil once we amplify it, because some of that might outgas, but we're going to cover it. We're just using a little tiny bit to hold that wire in place. So we're going to put this down and let that set for a minute. And you can use this exact same trick when you are rolling coils on a machine for an actual cutter head. Tiniest amount of glue will hold that. And now I'm free to take it off the machine and apply some other type of glue like an epoxy, or, if I was rolling these with the polyurethane resin and I'm going to bake them, then I'd already have that impregnated and I don't do the super glue. But if I'm going to use epoxy, I need to hold it first and then take it off and epoxy it. And just the tiniest amount of super glue is exactly all that you need to do that. So now we're going to seal this coil. And like I was saying before, masking tape is the friend of anybody making coils. And we are going to now use it to actually go ahead and seal this coil. And this is just a temporary thing. When I make coils for the 1D and 1C, I will usually use a very thin strip of heat shrink material. Tonight we're just going to run a thin cut strip of masking tape through here to kind of seal it off. And we're going to call it good enough. Okay? So that's what I just did. So, again, everything that I'm using is stuff that pretty much everybody should have around or can easily source. The 3 prints is the only exception, but you can actually go to your local library and have stuff you could print there, or you can have prints made by somebody in your community, or have a friend that has one. Other than that, the enameled wire, you can source that from out here. There's a place called Fry's. You can go to Micro Center. You can get this stuff from McMaster Carr. You can get it from DigiKey. You can get it from all sorts of places online. Nothing special. You can also, like I said, pull it from an old transformer or an old motor. So right now what I'm going to do is cut this lead. Give me some good length, but just cut it right there. I'm going to use my little trick to hold that wire without taping it. And now what we have right here, if we, like I said, I taped this in a way that I could pull off the tape and not pull on really the wiring beneath, and gently remove that. And I can now unravel this stuff. Here. If I can find the beginning of it. Okay. Now I'm going to hold these, because again, leads are very delicate. So I'm holding them in my thumb right here, and I'm pulling it out just so that I'm sort of straightening, because that one was pretty wonky from being wrapped around the rod, the winding rod. And I call that a winding rod because I also have winding rods. I have a whole bag of them for all sorts of different coil forms that go on my coil winding machine that allow me to wind different shapes and types of coils. And so now I can go ahead and get these two to be sort of in place. And I can pull my rod off. And boom. There it is. So for all of you playing along at home, you can make your own coil. It's really not particularly that tough to do. So what are we going to do now? Well, one thing that I would probably typically do is to do some strain relief on those leads right there, because they're really delicate, right? So I don't want to ruin them, especially right where they meet the actual coil form. So what we're going to do really quick is grab ourselves some heat shrink. And this might actually be something that people might not have at home. So if you don't, just be really careful with these things. You could also use a piece of shoelace, small shoe, like for dress shoes, actually. So I take that back. You could actually, if you take a piece of shoelace for dress shoes and you cut it and you pull the white piece from the center, you will have black or brown shell from that piece of shoelace. You can use that for the exact same purpose as what I'm doing right here. And then you could put a bit of wood glue over that piece of shoelace and it will do the exact same thing. It will be essentially the equivalent of that cloth-covered wire from days of yore. That brown cloth-covered wire that I had in the beginning of the video. So right now I just plugged in my enormous blue dildo. No, I'm kidding. My heat shrink gun. And careful with that, because you don't really want to get the plastic hot, because you can deform it. Oh, my kitty's wanting attention right now. So now at least I've got something so that these things are not going to flop all around. Right? I could actually glue that into place if I wanted to with another little piece of glue. But I'm not sure I'm going to do that right now. Maybe. Why not? Just sort of fix that into place. So this kind of gives you a notion of, okay, yeah, I mean, coils are not that hard, and yeah, okay, I can sort of piece it together from this and that, and yeah, okay, you know, careful about the leads, and yeah, okay. Not that tough. So, as I was saying in the beginning of the video, evolution. I didn't start from nowhere. The first coils I made, and you can actually go backwards in my YouTube stream and find some videos about the first coils I made. They were on some blue printed plastic. They were pretty rough, man. They were not that pretty. Hi, Poppy. My doggy really wants to do something with me right now. So what I'm doing is taking a razor blade, and I am holding down on the end of this, and I am very carefully just stripping the enamel off. And I think you might actually be able to see maybe that there is a difference in color now. I've taken some of the red off, and it's just copper. And so now I'm going to sort of turn that wire and do this exact same thing. And I'm going to do that a couple of times so that I can get as much of that enamel off as possible. But I'm going to be gentle because I don't want to just snap the wire. The smaller the gauge of the wire, the more gentle you have to be because you will just simply slice it. So be very gentle with the much thinner wire, much larger gauged wire. 32 is relatively easy to work with, so that's why I selected it for tonight's video. And it's not going to have the heat buildup that something along the lines of, like, you know, a 20 gauge is going to give you. So now we've got some pretty clean wires. Ends. I've taken the enamel off. We're going to be able to actually, be able to actually measure this coil now. Highly recommended. I've already eaten all of them, so they're done. But, or not quite all, but almost all. So, doesn't matter polarity. I've turned it to 200 ohms, not 2K or 200K, but 200 ohms. And I'm grabbing these two coil leads, and I'm going to just wrap them around the ends here of the probes. And you can see this coil measures about 8 ohms. DC. That value is actually incorrect, and I'll show you the correct one later. 8 ohms, ladies and gentlemen. DC resistance. Now we are going to grab out the audio impedance meter. And we are going to say, where the heck did I put the probes for this? There they are. That was almost a derailing. Again, it doesn't actually really matter polarity, but I'll plug in red to red and black to black just to be consistent here. And let me get the cover off. Turn it on. I turned it on to the first setting, just 200 ohms, because I know that this is not in excess of that by any means. This will be fun. How do I get you to stand up? Can you? Nope, you're not gonna. So I'm gonna have to connect this and get it going, and then I'll tilt it so that you guys can see it. But I hope that this demonstration points out to everybody that this is accessible. This is not impossible. And really, if you want to make some good stuff, you got to incorporate metal into your design. You can't just use plastic. But plastic is good enough for an explanation, a show and tell. So now we're going to measure this coil as far as AC impedance is concerned. I'm going to hit the button, and it's starting to run the test. And you can see that this measures 6.8. I think that you can see that. Maybe not. So this value is also incorrect, but for a different reason. I will show you the correct value and explain why I was getting incorrect readings here later. Now we have measured this both DC and AC, and we know that it works. Right? This works. There was no short circuit or anything, so this is one continuous piece of wire. And I'm fairly positive that once we run current through this with audio, AC current, that it's going to do what we want it to do. So what I'm grabbing right now is this guy. Let me actually... Okay. So as I was saying earlier, these are stand-ins that you can use for the connectors for the Presto cutter heads. And we're just gonna plug those in. I made this I 3D printed it and used one of these off-the-shelf connectors, and it just makes it convenient for this sort of thing. You know, little grommet there, and these on the other end. And now I can take this, just bite down on it. Do the same, take this, bite down on it. Get down on it. If you really want it. I see that there's some enamel still on one of the sides here, so I'm gonna, again, ambidextrous, get that off. Now, I'm going to go ahead and I'm going to turn on my amplifier and start my MP3 player, which has some of Brian's music on it. This will be the track, The DL, Brian Gardner. I know, Katie, I'll be there soon. I'm almost done. We are almost done, by the way, everybody. So if you have bared with me this long, thank you. If you're watching this live, thank you. If you are watching this after the fact, thank you. Thank you for your interest in my work. Please subscribe and support me in doing that, and I will show you more cool shit. If you don't, I will stop showing everybody stuff. I will finish this series nonetheless, but I do really need some support, so please subscribe, please hit like, please comment. If you have questions, let me know. Okay, so we've got some audio now. It should be playing. And the fun thing is, you can just grab magnets. You can bring them close to this, and you can hear. So I'm going to raise the volume because it's not quite... Oh, I know why. My MP3 player itself, the volume was down, so I have my amp at about where it normally needs to be, but the... And what's funny is, right now, you can hear audio. Here, so it's... The reason why you can hear audio is because it's self-exciting. So, congratulations, you have now proven eddy currents exist. And this is just, this is a single disc magnet, which is pretty beat up. It's missing most of its cover. It's a neodymium, so you would want to use a neodymium for this, and a disc magnet like this. I also just have a couple of other ones on the end, which will increase the strength of the field around this disc magnet. And you could hear it. And in fact, if you try this yourself, you're going to feel this. It really, really works. And it's cool because that's sort of your eureka moment. When you can actually bring those two things together and you feel it, that really kind of cements this for you. So let's take this one step further. If you've seen any of my cutter head videos, you've seen me use a cup, right? And it's just because it's a nice horn, right? It's basically like an old gramophone. This is your horn on an old gramophone. Guess what we're going to do? We're going to just glue this to the end of this. And then we're going to hold the cup so that we don't have to hold the coil. And we're going to bring the magnet to it, and we're going to hear it. And that's going to be our speaker. Not just hear it, but feel it. Again, that's your eureka moment. That's where everything comes together. So I'm not going to use the side that has the leads coming out. I'm going to use the other side, this side right here. And then I'm going to pretty much call it after that. There's going to be more explanations in further videos, so please do check out the rest of this series. Watch me finish out the Presto 1D and the 5C, and get your eureka moment there, right? So I'm going to do the other side. I'm going to put some glue just on this side. And this stuff is great. It's from Harbor Freight. It is industrial strength, fast drying, very liquidy super glue. It's the easiest super glue I have ever worked with. I can't recommend it enough. I just put some on the one side, and I tried to just center it by eyeball and just glue it on the end. And any kind of cup, any kind of plastic cup will do, even a paper cup. Either way. Don't use don't use an actual glass cup or anything hard. You need something that's like this. So that's already set. Right? And we're going to do the same experiment here, this time with the correct track. So actually this time with my friends Brian Gardner's track, the DL. You can feel it when it's at certain places. When it's really close, it works really good. You get more highs when it's closer. This is more bass. When it's not as close, the magnet is what I'm talking about. So when it's really close, you can actually see it pushing itself away from the magnet. Congratulations, you've just become a speaker. But I think that you should also understand that if you're actually playing along at home, I should have given you the mental flame to spark your brain, my friend. This is not impossible, and you can achieve it too. And you can make your own transducers. Don't buy off-the-shelf speakers. Make a cutter head with real parts. It's not hard. that I've inspired some people. Thank you very much for your interest in my work. Please do continue to watch this series as I continue to demystify and later debunk, but we'll get to that. But for now, demystify. Hey everybody, I wanted to film a bit of an update here, an addendum, a follow-up to the Twitch stream, because towards the end there was a bit of a problem and I knew that it was something wonky was happening while I was streaming, but I didn't want to derail the whole thing, so I'm now filming an update. So a couple of things. Number one, this meter, which by the way, somebody asked me the actual model, make and model of it, so I'll put that up on screen. It's a Tenma 72-6948 audio impedance tester. Can't remember where I got it from. If I think of it, I'll bring it up. Anyway, that's what this is. When you actually run it, when you turn it on and run the test with the probes connected to themselves, then you can zero it out. And so when in a prior stream, I had shown this meter and I had shown that you can do this, which is turn this knob to do that adjustment. Well, I forgot to actually run the test, and so that was out. So I'll give you the example. Right now, if I run the test with the probes connected, you can see that that's not reading 0, it's reading 2.4. It should read 0. And you can go the other way too, so negative or positive. I'm going to get it to the 0 point right there. Now this will actually give you a correct reading. So I screwed myself up by demonstrating that knob in a prior video. So that was one problem. Another problem was that, as it turns out, one of these connectors, these have two pieces that screw together. One of them was loose, so I had sort of a bad connection to begin with. So I was getting incorrect readings. The thing that really tipped me off was that your DC resistance should always be a lower value than your AC impedance, unless you've done some kind of real true magic or your coil is very strange. Your DC resistance should always read lower than your AC impedance, and it wasn't in the video. So that sort of, in retrospect, is what tipped me off. This is the exact same cup setup, so there's nothing changed, and I just taped it down. There's nothing on the inside. We're not cheating or anything, right? I just made it so it wouldn't move around. So I'm going to tape it down again. And so what we're going to do real quick is remeasure this coil and then do a bunch of other fun things to just show you a bit more, to give you more examples of all the things that I talked about in the other part. So first off, what we're going to do is measure the DC resistance, and this time measure it correctly. So I'm going to put this to the lowest resistance value. I'm going to grab its probes, which are right here, which do not have clamps, and I will put it on to these two guys right here. Because I did this before, I know what it should read. There we go. And of course, that's out of frame, so let me zoom in. And we should read right around 5. 4.9. 5. So that's what the resistance, the DC resistance of this coil is. And that is correct. It was reading something else in the video. So that was an error. So now I'm going to run this test. Okay. And what I just did was turn this to the smallest voltage setting, and we'll get to that in a second. So now let's do the coil with the AC impedance meter, and I'm going to put it on the lowest setting, which is 200 ohms. And I'm going to use these probes because I now have a general idea by doing the DC resistance what the range of the AC impedance is going to be. This goes up to 20k ohm, by the way. It takes 8 AA batteries, and do not connect these 2 leads with your finger. You will get zapped. It does put out a pretty good charge, man. So look out for that. Now, right now, it's not going to do anything because I'm not running the test. So I have to hit this button, it will run the test. Now you can see that the AC impedance is in fact reading higher than the DC resistance, which is correct. So what we're going to do right now is take these magnets here. Oh, another thing real quick to mention is it will read differently, as I said before, based on its environment. So if I take this piece of steel, which is all this is, it's a piece of steel that I machined on my lathe, mini metal lathe, and I put it on top of there, which is all I did. I just set it right on top of that coil. And now it reads 5.6. And if I take it off again, it's 5.5. And that is definitely an effect from the steel, right? So if I take, for instance, something else which is almost the same shape and size, which is this piece of printed plastic, and I put it on top, it has 0 effect on the value. So for sure, coils, once they're embedded into their respective systems, which generally include some kind of steel, and by the way, soft steel is the best for this sort of electromagnetic stuff. Stainless steel is the worst. Don't use stainless steel. Okay. So another thing that I should mention real quick is that this guy will, here, the lead I think is a bit wonky here. There we go. That should really be reading 5.5. Now, again, I've had some, like the wiring right here where it meets that. Every time I move it just slightly, fucks it up. But messes it up. But that should be 5.5. DC resistance should be 5. In order to measure AC impedance, you actually have to run a signal of a known frequency. And so I'm going to bring the microphone close. And you can actually hear. Whoop! Of course. Once I put the magnets there. One more time. I'm holding the magnets. I've got the microphone close. And you should have been able to hear just slightly a sort of. And that tone is the tone that's generated by the AC Impedance meter in order to measure AC impedance. So now we've done that. One other thing that we're going to do real quick here is run some audio again. Okay, so I'm going to grab up these magnets and I'm going to turn up the volume on the amp. And I'm going to bring the magnets close. And I'm going to connect the audio. My cat's going to the bathroom. Okay, so we can hear that again, right? And it's actually moving the magnet. So, I don't need it quite that loud. I'm going to turn it down just slightly. And demonstrate something. So if you bring the magnet this close, you don't really hear it very distinctly. Right about here. If I take this piece of folded steel and I put it on the magnet in a way to extend the field of the magnet, you may not be able to tell on the video, but you can tell in real life that you're getting a lot more of an interaction with the coil. So the magnet by itself right here, not as loud as if you extend its field. So pieces of steel will actually allow you to extend, to shape, to manipulate, change, to alter, to move the magnetic field that's generated by this thing to where you want it to actually be. So that's something to keep in mind. This is another coil. A couple of leads here. And take this secondary coil and I'll pop it on top of that coil. I'm going to put this piece of steel, it's just a piece of steel, nothing special. I have a little bit of printed plastic on top, but we're just making a little bit of a coil sandwich. I'm going to take this piece of tape here, just a little piece of painter's tape, and just sort of hold things together. Okay, so now we've got two coils, steel core going in between, right? And what we're going to do is turn on the ohm meter. And I'm going to connect these leads to those leads. So that's what I just did, is connect the coil leads, the secondary coil leads, to the ohm meter, right? We're actually making so much voltage that I had to change settings. I don't know if you just noticed that, but 200 millivolts kept 0Ling, which means that it was actually getting more. So we are now actually generating voltage, and I'll prove it to you. I'm going to disconnect one of the audio leads, and that goes down to 0. So, you know, we're not cheating here or anything. Like, this is for real. This is actual voltage being generated as a result of the primary field that's being created by this coil and assisted by this piece of steel. If I pull the steel out, we're going to get lower readings. You see that? We're down to 2s. If I put this in, we're going to go up. Now we're up to peakings at, you know, some peaks are at 0.7. Look at that. So this right here is a total example about why it's tough to do feedback without actually getting, you know, true interaction between the two coils. Feedback that way, if you will, not the feedback you want. This is also a demonstration of why what's called motional feedback just does not work. You know, it's limited, very limited in the frequency range that it can work in, because it is primarily a result of the you know, interaction right here, induction between the one coil and the other. You know, so what's called motional feedback is 90% induction and can only be useful for a frequency range of 200 hertz and below, which is pretty, you know, unusable, so to speak. Something else that we're going to do real quick here is we're going to drive this coil a little bit harder than what we're doing right now. And I'm going to show you two things. I'm going to show you heat, and I'm going to show you the effect of the field in another way. So let's get this guy off again, just a steel rod core. Let's take the tape off and get this other other coil out of the way. Right. And again, you can see the meter went down to 0. You know, whoops. So another thing that you could do with this guy, right, is bring it around to different places and look at what you're reading on the meter and be able to see, oh, okay, the field's good here, the field's good here, especially if you're starting to incorporate the metal pole pieces into your design. It's kind of good to be able to take measurements of some way of your AC field And that's a way that you can do it. You make a coil, you can hook that coil up to a meter, and you can just straight read voltage that's being generated. It's the simplest way possible. So right now, you're not really hearing much. If I do turn up the volume a lot, we will hear something, and I pointed out before, you can't sort of hear it right now. And there's no magnets. It's just by itself. It's making that. So that's proof of Lenz's law. That's proof of eddy currents and how they're in opposition. And so this thing is creating a small field in opposition to the primary field, which is causing it to move by itself. You know, no magnet required. If I turn up the volume, though, on the amp, we can really hear that effect. And I mean, again, I'll move everything else out of the way. That thing's just sitting there by itself. So what this is just, I took a bunch of, so resistors. Resistors are, let's see if I get the light so that you can see. So down inside of there are trimmings from the legs of a bunch of resistors. I just took a bunch of resistors and trimmed the legs into little tiny pieces. And look at that. They move around. Did you see that? You can see that in there. So you can sort of see them jumping around. This is probably something that's not going to be too great on camera, but definitely something that you can try yourself, and it does absolutely work. These guys are jumping around. Maybe not terribly much right now, but right now that's because this guy's heating up and it's changing resistance. So right now it's getting worse. The response is getting worse and worse and worse because this thing is actually getting really friggin' hot. Back up here. Get higher up. So I've read peaks of around 200 or so. Plastic's starting to melt. I can see it. This thing is actually smoking, so I'm going to turn it off. Right? There was a little bit of tiny smoke coming out. Still is. So I had to turn it up a lot to get these guys to dance, but they do dance, and then the effect started to taper off because that thing started to get hot, and as it started to get hot, its resistance changed, and the impedance went way up, and it started to not work really good. And so that's why you need to be concerned with heat in your system, and it is still actually smoking a little bit. You probably don't see it on screen, but or see it on film. But it was, suffice it to say. And so that thing got hot, you know. Ambient temperature in the room is like 70. So that thing I was reading, I saw a peak or two that was like 200 and something. So you have to get it at just the right place. But again, having one of these is good, right? To be able to tell how hot is hot. Okay, final couple of things to show you here. So now instead of driving this from my audio amplifier with music, I'm going to drive this actually from a power supply. So this is a wall wart DC 5 volt half amp, your standard USB style power supply, right? Not a huge amount of current, basically. I'm going to take this guy and tape it down so that it makes it convenient for us to work with here. Okay, so we just taped down this power supply, and I'll bring the cup around here. Right, so cup's there, coil's there. It is still functional, I think. Grab up this guy, which is an AC/DC meter. However, if you don't have the other probe, the other style probe, it will only be DC. And so, like I said before, you can just make an AC meter using a coil. Now, the specs on the coil that I have made here are not really great for, or the one that I was using before, are not good for, i.e. the gauge of wire, really. It's not what you would want as a something that you would receive charge from, right? So how I was using it is inverse to what it was made for. That's basically what I'm saying. So now I've got my DC Gauss meter here and this guy, and what we're going to do is run a bit of DC current through here, and we're going to see what the DC field value is going to be that's generated in response to that current. Okay, so that's what we're going to do real quick here. And so with DC, there'll be no audio. If I put the magnet by there, you're not going to hear anything because there's no audio being generated. There's no movement. It's only a field in one direction, and it's not flipping. So there'll be no effect like that. You won't hear anything, but you can certainly measure something for sure. You'll be able to measure the field, and then we'll be able to do one more fun thing towards the end there. So let me get set up for the one last fun thing, which I don't know where that went. Okay, we'll have to find that in a minute. Oh, there it is. Okay. All right. So I'm going to zero this guy out. Okay, it's now at 0. And I'm going to go ahead and use my screwdriver here. And I'm going to get one of these guys. Well, it's possible that these aren't going to fit. Yeah, no, they're not going to. So I'm going to have to just sort of hold it. So let's get everything set up ahead of time. That's funny because this plastic looks very shiny right now, so I could totally tell that it got overheated. What I'm gonna do is sort of, actually I'll just let it sit like that. That'll be fine. That'll be totally fine. I'm gonna make sure that we can see the value on the screen, and you can now see that. Of course, that moved that. So there you go. You kind of want this to be flat on there, as flat as it can be. And right about there will be okay. And I'm going to connect this guy. And we're going to see a field. We see a field of 2.5. And I disconnect it, and boom. So the field collapses. If I connect it the opposite way, we should see the same value, but the reverse polarity. But we're not getting quite the same value. Let's go this way again. I think it just has to do with me moving these leads around in a wonky way, and I'm not actually screwing down on these terminals. Oh, I may have fried the coil. Oh, no, I just moved this guy. Okay. Ha 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 ha. Not watching. So let me try to fix that real quick. Okay. So this guy moved. I'm like, why am I not getting value? Okay. Now, let's connect this one way. All right, there you go. We're getting a field of 6.6, and that says south. Now I'm going to reverse the electrical polarity. We're getting a field of, this time around 5.7 and north. And so, again, I think some slight variances are just because of connection issues right now, but you get the idea. You can actually measure that guy, and it will be north or south if you just run audio through it, or not audio, signal through it that's DC instead of an audio signal that's AC. Okay, and so final little bit of fun. If we put this guy on here and we do actually run some DC through it, we're going to have it jump right off of there. It's either jump off or it's going to be attracted. It just depends on the polarity. So I might get lucky, it's 50-50 chance, and it might jump off the first time. Or I might have to do this twice, and it will jump off the second time. But all I'm going to do is make the connection here, DC. And so again, we'll either get an attractive force or a repulsive force. And we got a 50-50 chance. We got it right. That was repulsive. It just jumped off. We just have proven, demonstrated, shown, made accessible a ton of different principles right here in this short little follow-up. So thank you all, for joining me, and stay tuned because we're going to roll coils in the next stream. Thank you again. So, Upcode 66, Deep Grooves Mastering. Please check out my YouTube channel and subscribe. Thank you very much for joining me tonight. And next time we will wind on my actual coil winding machine, the coils for the Presto cutter heads. If you dislike my work, or me more especially on YouTube, please comment and ask questions. Please subscribe. Be well. Take care of yourselves. Be kind to others, please. Can't stress that one enough. I'll see y'all next time. Namaskar.